out of methyl and ethyl. It was easier for ethyl. It was easier for ethyl to shift. Yes or
Right.
no? It was easier for ethyl to shift. Got it? Now understand. So when this was happening,
Yeah.
that out of ethyl and methyl, it was easier for ethyl to shift. Now similarly, we have this structure. We have this, right? And we have a CH3 group here, and we have an isopropyl group here, like that. Okay.
Okay.
And I want you to calculate, this. So we will have this part, and we're going
Mm.
to have HCl. So when we have HCl, what does that mean? Just tell me. So we will have HCl, and that HCl is actually going to break.
Yeah. H plus and Cl minus Cl minus. Okay.
So when HCl is going to break, you know that
So
H plus and Cl negative. H plus obviously runs from here,
yeah.
so it breaks, and when it breaks, so understand. So HCl, you understand that HCl is here, is actually in the aqueous form, okay? Because otherwise HCl will not break on its own. So first of all, you have to understand that who is actually helping HCl to break down. HCl itself is a covalent molecule, and HCl will never break down on its own. So we'll have HCl. It's going to be partial negative and partial positive, right? So what do we have in here? So we'll have
Right.
O negative. O carries a negative charge, and H carries a positive charge.
Mm.
Similarly, we'll have H2O. This is negative and this is positive. And we'll have H2A.
All right.
Are we understanding? So what is this happening? That O negative
Mm.
is going to pull H plus, O negative is going to pull H plus, H plus is going to pull Cl negative, and that's how this bond is actually going to break. And when this bond is actually going to break, so we'll have cross and dot. Understood my point?
Yeah.
Right. So that's how HCl breaks. So that means we have a water here already. And water is also a potential
Mm.
nucleophile, right?
Right.
So that is one aspect of it. Just see. So then I'm just saying that water, because of water, HCl molecule breaks down and it gives you H plus. Perfect. This bond opens up. So we have C,
Mm.
CH, CH3, and a CH3, and CH3 here, and a CH3 here. And this bond opens up, and we acquire a CH positive charge. Are we understanding? Yes or no?
Yeah.
Now, this is a 2-degree
Yes.
carbocation. But in this structure, this carbocation has high possibility that it can shift to this carbocation also. So when we have this carbocation,
Right.
and when this shifts here, what does that mean? That this can shift here or it can shift here? Yes or no?
Yeah.
So as a result, what do you think is going to happen? So going to have CHAC. But you realize that these two electrons are also getting attracted towards this. These two electrons are also getting
Mm.
attracted towards this. But because they are getting
Yeah.
attracted, so this C acquires a positive charge. And because this C
Mm.
acquires a positive charge, what would that mean? That these CH3 and this CH3 is donating electrons to this CH3. As a result, the positive
Right.
charge here reduces. So that is why when these electrons are shifting here, this positive charge is unable to pull back the
Pull it
electrons.
back.
And
Right.
as a result, the shifting of isopropyl group is better. So this is my isopropyl group. Even though it is a bigger group, it's a heavier group, its shifting is little difficult. So thereby, its shifting is because of its weight, its shifting would have been difficult. But because of the support it is getting from the two methyls, it is able to shift from here to here. And thereby we get CH3, C, CH3, and a positive charge here. And on this CH, we get this isopropyl group getting shifted. So we will have CH3. Are we understanding this point?
Yeah.
Okay. So this is going to be my 3-degree carbocation. Now, there is another aspect to this, first of all, that we have two CH3 groups connected here, right? This is one part. Now, second part here would be that we will have a C plus, then we'll have CH, to which an isopropyl group is actually connected. And then we'll have CH3, we'll have CH3, and we'll have CH3. So first of all, it's a carbocation being formed. And here carbocation formation is actually is this rate determining step. Carbocation formation is actually the rate determining step. All right. Now, what do we
All right.
understand by the term rate determining? Just let's see. So now we have two electrophiles here,
Just
two nucleophiles here. We have water and
mm,
we have Cl negative. Okay. Now, because we have water and we have Cl negative, what do you think is going to happen? Who is a better nucleophile? Or obviously a negative electrophiles. A negative nucleophile
right.
has more nucleophilicity. That means it can, because its negative charge is very much evident and it is seen there. The negative nucleophile has more nucleophilicity and it gets, or I would say it carries more negative charge. It carries more negative charge. And when it carries more negative charge, what does that mean? It gets attracted. So out of water and Cl negative, who experiences more force of attraction? It is Cl negative. So we will have CH3 and we will have a CH3 and we'll have CH and CH and CH3 and CH3 and CH3 and Cl will be attacking. Are we understanding? And obviously Cl negative can attack from any of the sides, top or bottom. So this reaction, this attack is not specific. स्पेसिफिक का मतलब क्या होता है कि भाई या तो टॉप से अटैक करे या बॉटम से अटैक करे. इट इज नॉट स्पेसिफिक, वो कहीं से भी अटैक कर सकता है. 50-50% पॉसिबिलिटी, 50-50% पॉसिबिलिटी ऑफ द अटैक फ्रॉम टॉप और बॉटम. इज दैट क्लियर? सो दैट मीन्स जब हमारे प्रोडक्ट्स में ये हो जाता है कि प्रोडक्ट कुछ भी बन सकता है, टॉप अटैक के बाद जो प्रोडक्ट बना वो भी बन सकता है और बॉटम अटैक के बाद जो प्रोडक्ट बना वो भी बन सकता है. तो जब ऐसा हो जाता है तो हम बोलते हैं कि हाँ जी, तो हम क्या बोलते हैं कि हाँ जी हमारे पास ये प्रोडक्ट स्टीरियो स्पेसिफिक नहीं है. स्टीरियो स्पेसिफिक कौन सा रिएक्शन होता है जिसमें क्लियर है कि भैया एक बीआर ने बॉटम साइड से अटैक किया तो दूसरे बीआर को टॉप से अटैक करना ही है. मतलब
Okay.
उसका प्लेन, उसकी पोजीशन डिसाइड हो गई पहले से ही कि भाई अगर एक बीआर ने बॉटम अटैक किया तो दूसरा बीआर टॉप अटैक करेगा ही. यू अंडरस्टैंड? लेकिन जब हम
Yeah.
बात करते हैं किसकी, जब हम बात करते हैं हमारे इनकी, किसकी, जब हम बात करते हैं हमारे इसकी, दिस अटैक इज नॉट स्पेसिफिक, इसकी जो सिन अटैक जिसको हम बोलते हैं, एक्चुअली
Hmm.
सिन अटैक डिफाइन करना बहुत मुश्किल है. लेकिन क्योंकि साइंटिस्ट ने बोला कि सिन अटैक होता है तो उन्होंने उसका जस्टिफिकेशन दिया. उन्होंने उसका जस्टिफिकेशन दिया आयन पेयर अटैक. उन्होंने बोला कि जब एच अटैक कर रहा था ना, एच प्लस और सीएल नेगेटिव एक साथ खींचे खींचे आए और जैसे ही एच प्लस नेगेटिव पर अटैक कर गया तो सीएल नेगेटिव निकला. तो सीएल
Hmm.
नेगेटिव नियर बाय उसी प्लेन में था जहां एच प्लस था. तो इसीलिए वो सिन अटैक एक्सप्लेन कर देते हैं. बट जनरली सिन अटैक जैसी कोई चीज होती नहीं. ठीक है.
Okay.
तो दैट्स वाई. बट सिन अटैक हम बोलते हैं तो हम कहते हैं चलो सिन अटैक हम मान लेते हैं, स्टैंडर्ड बुक्स में ये लिखा हुआ. क्लियर?
Hmm.
करेक्ट है. तो दिस इज माइग्रेटरी एप्टीट्यूड, राइट? अब आप देखो लॉजिक. ठीक है, दिस इज वन पार्ट ऑफ इट. नाउ 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 दिस इज वन एस्पेक्ट. नेक्स्ट वी हैव व्हिच इज हाइड्रोबोरेशन, ऑक्सीडेशन, right? This is addition of water. This is also addition of water.
Okay.
लेकिन ये addition of water किसकी presence में है? This is the addition of water in the presence of BH3. Okay. This is the addition of water in the presence of BH3 followed by ROH, alcohol, followed by H2O2, followed by base. तो ये चार reagents हम डालते हैं. ठीक है. अब कैसे डालते हैं देखो.
Hmm.
तो सबसे पहले इसमें हमें कुछ कुछ की प्रॉपर्टी बतानी चाहिए. What is BH3? BH3 is called as borate, highly unstable gaseous product, highly unstable gaseous and explosive product. तो इसको
Okay.
बहुत लो टेम्परेचर पे हम लोग कराते हैं. ठीक है. अगर ये एक्सप्लोसिव प्रोडक्ट है तो कैसा है, क्यों एक्सप्लोसिव? आप सोचो, ये रिएक्टिव बहुत है. आप सोचो बोरॉन का एटॉमिक नंबर इज 5, कॉन्फ़िगरेशन इज 2 3. तो यहाँ पे ये एक कोवलेंट बॉन्ड बनाता है हाइड्रोजन के साथ. अब जब भी हाइड्रोजन के साथ कोवलेंट बॉन्ड बनाता है तो हमने कहा ठीक है BH3 बन गया. But if you look at this
Hmm.
configuration 1s2, 2s2, 2p1, तो बॉन्ड बनाते समय इसने क्या किया था? अपनी ग्राउंड स्टेट में तो बोरॉन जो था उसके 2 इलेक्ट्रॉन्स 2s में थे और 2p सब शेल में 2px होता है, 2py होता है और 2pz होता है. तो एक इलेक्ट्रॉन यहाँ है और 2 इलेक्ट्रॉन्स यहाँ है. बताओ है ना?
Hmm.
So the idea here is what? The idea here is what? That, ma'am, this electron is going to shift here and
Right.
thereby we will have 3 unpaired electrons. So we'll have 2px and we'll have a 2py and we'll have a 2pz. Understood my point, ma'am?
Yeah.
So the idea is that we're going to have 1s2, 2s2, and we're going to have 2p1. And now when we have 3 electrons unpaired, we still have a pz orbital,
Hmm.
which is vacant. So this boron will have a 2pz orbital, which is going to be vacant. Because 3 orbitals will be utilized in making the sigma bonds. We will do this in detail. Okay. So when you say
Yeah.
that boron has 3 unpaired electrons, where are these unpaired electrons in? They are actually in the hybridized orbital. Are we understanding?
Hmm.
They are actually in the hybridized orbital. So I said,
Right.
fine, they're in the hybridized orbital. Good enough. Now, what exactly happens? So we have borane, right? Borane has 2p set. That means it has one orbital free. And because of this, this is highly reactive. This is highly reactive because borane can easily accept a pair of electrons. It can easily accept electrons. And the moment it accepts electrons, it starts to make bonds with anything that comes in contact with. You understand? So then what exactly happens is that so this is very explosive, very unstable, gaseous. Are we understanding this part,
Hmm.
Anika? Okay. Now, what
Yeah.
is happening? So what do? We keep boring. Now, also you have to understand that out of BH3, boron's electronegativity is less. Boron's electronegativity is less than hydrogen. Okay. So this is going to carry a delta negative charge and boron is thereby going to carry a delta positive charge. That means once the bonds are formed, the shifting is more towards hydrogen. So now let's say we talk about CH3, CH, CH2, and we add BH3 to it. All right. Once we add BH3 to it, what exactly happens? You see, what exactly happens? See, alcohol is basically, so what did I write down first? I write down BH3 slash ROH. Now, what is BH3 slash ROH? ROH is a solvent for
Okay.
borane. Why it is a solvent for borane? Because you understand, if I leave BH3 like this, so its p orbital will always be vacant. So it will always be super ready to attack and combine with other species. How does alcohol act as a
Hmm.
solvent to it? Alcohol acts as solvent to it. That it meanwhile it keeps giving it electron and makes the bond with it. So basically, alcohol
Okay.
dissolves borane into it by giving its one electron and keeping one electron with itself, and hence making a covalent coordinate bond with borane. So that is how
All right.
BH3 remains dissolved in alcohol and its explosive nature is reduced. Okay. Otherwise, if what do
Hmm.
you mean by something? What do you mean by something being explosive? Being explosive would mean that it is highly reactive. The moment it comes in here, it catches fire very quickly. So what exactly do you think is happening here? That you will have ROH. Got this? Now, what exactly happens? So what do
Hmm.
we do? So borane is there. Borane remains dissolved in alcohol. And because borane remains dissolved in alcohol, so we will have BH3. Okay. Now, what is happening here? We'll have BH3. We know that the tendency here is to make the most stable carbocation. So CH3 pushes the
Right.
electrons. Pi bond opens up. And because the pi bond opens up, so situation something here looks like this. CH, CH2 negative, and this is positive. Okay. And in the BH3 structure, what do we have? We have this is carrying partial delta negative, and this is carrying a partial positive bond, right? So how do I structure it? I structure
Hmm.
it like this. So we'll have BH2 and H because 3 BH3, 3 H we have. Are we understanding? So once we have
Yeah.
3 this, This is partial negative. This is partial positive. So that's how the borane molecule aligns itself along propene. And now a
Okay.
transition state is formed. What is transition state? Because the double bond is about to break, so we show that we'll have CH3, we'll have CH, we'll have CH2, we'll have H dot 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 BH2. And because boron is carrying a positive charge, so that is highly likely to attack itself to the negative. And del H is carrying a delta negative charge, that is highly likely to attack itself on delta positive. So this is a four member. So these kind of questions are asked. That what kind of transition state is actually formed? So it's a four-member transition state is formed in hydroboration oxidation.
Okay.
Hydroboration oxidation, I call it as HBO, the short form. All right.
Fine.
Any doubts in this? Right. So we have hydroboration oxidation happening. And hence, what do we say? Hence, what do we say? That we have hydroboration oxidation occurring. Fine. So this has happened. And then what you realize here
Okay.
that we'll have CH3, we'll have CH, and we'll have CH2. To this CH2, we have BH2 connecting, and to this, we have H connecting. And old bonds basically break, new bonds basically form, old bonds break. And what was the older bond between B and H?
Right.
Old bonds break and
Break. New ones are
new bonds
formed.
are formed.
The CHH and the
Are we
CH2
understanding?
page.
Got the
Yeah.
point? Right. Now, this is one molecule. Then another molecule comes. So now this one molecule becomes highly active. Then we have another propene molecule coming up. We'll have CH3, CH, double bond to CH2. Right. So once we have this, again you realize that this molecule becomes what? CH3, CH2, CH2, BH2. Again, B carries a partial negative, positive, H carries a partial negative. So again, this molecule aligns itself along this, bond opens up. This is partial negative, partial positive. So how does it align here? So we'll have a CH2, CH2, and a CH3. Are we understanding my point or not?
Yeah.
Okay. So again, the old bonds are breaking, the new bonds are being formed here. The old bonds are breaking, and the new bonds are being formed here. So what do you think we have? We will have a CH3. Okay. We will have what? We will have a CH3, CH, and a CH2, and H. Then we'll have a BH. Then we'll have CH2, CH2, CH3. And new bond here shall be formed, and new bond here shall be formed. Are we understanding this part? So we'll have a partial negative and we'll have partial positive. Again, this bond breaks. This is bond breaking, BB. This is bond making BM. This is bond making BM. And this pi bond is breaking. This is also BB. BB means bond breaking. So what do we have in here? We'll have CH3. We'll have CH. We'll have CH2. CH2. And what is this? BH. And we'll have a CH2, CH2, CH3. Understood? So how do I write this down? I write it down BH, CH2, CH2, CH3 whole twice. Understood my point or no?
Yeah.
Are we understanding?
Yeah. Can you just give me 1 minute?
Yeah. Oxidation. Understood? Similarly, we still have one BH. We still have one BH, right? So then what do we have? Then what do we have? This is another molecule. So third molecule of propene comes. So we'll have CH3, CH double bond, CH2. And we will have what? we will have BH connected to CH2, CH2, CH3 whole twice. Again, how does it? Now, this is my third propene molecule. All right. Now, this is my third propene molecule, see, understand. Again, the process remains same. B carries a positive charge, H carries a partial negative charge here. So this is a really different case. Why I'll tell you, because in normal cases, H carries a positive charge and B carries a negative charge. So what does that mean? So we'll have this, and we'll have an H here, and we'll have a BH here, and we'll have CH2, CH2, CH3 whole twice. Got the point? Got it? So we'll have this, and H here is going to have a positive charge, negative charge, and B here is going to have a negative charge, positive charge. Bond as opens as usual. So we'll have what? We'll have CH3, CH, single bond, pi bond breaking, new bond being formed
Mm.
between BH, bond breaking down, and this bond here. So we'll have a CH2, CH2, CH3 whole twice. Understood my point or not?
Wait.
And then
Where did this
what is
extra
happening?
H come from?
I'm so sorry. This is right? Yeah.
Yeah,
Got
wait,
it?
but in the previous step, where did
Wait,
this H come from? Oh yeah, fine, got it. My bad.
got it. Yeah. Then what do we have?
Yeah.
So we'll have CH3, CH, CH2, H connects here. Oh, sorry. Positive, so this is negative. I'm so sorry. This should have been written like this. Negative B is positive, no? So B, CH2, CH2, CH3 whole twice, and dot 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 H here. So we get this, and we are connecting itself to borane, and then we'll have CH2, CH2, CH3, and then we'll have CH2, CH2, CH. Got the point? So here, what do you think we'll have?
Yeah.
We'll have boron, and borane is now all the H gradually are replaced by CH2, CH2, CH3. Understood my point?
CH3.
Got it?
Yeah.
Step by step, this is happening. And just align it that way that this carbon carries negative charge, this carbon carries positive charge. So towards negative, positive aligns. So who aligns here? B dot 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 H, and we'll have a CH2,
Mm.
we'll have a CH2, and we'll have a CH3 whole twice. Are we
Right.
understanding? Got the point. So we'll have
Mm.
this. And then obviously new bonds are formed. Now, so we have this part. So we'll have borate, we'll have a CH2, we'll have a CH2, and we'll have a CH3. We'll have a CH2,
Yeah.
we'll have a CH2, and we'll have a CH3. Then we'll have a CH2, then we'll
Mm.
have a CH2, then we'll have a CH3. And the lone pair is still intact. The empty p orbital still is intact. Understood
Right.
my point? Got it? Now we have
Yeah.
hydrogen peroxide, HOOH. And you have to understand that hydrogen peroxide is a weak acid. But
Okay.
because it is an acid, why is it an acid? First of all, you understand that it has this OH bond. Any substance having OH bond can behave like an acid. Why? Because O is highly electronegative. So it pulls its
Mm.
own electrons and the H is electron towards itself. So H acquires a partial positive charge and O acquires a partial negative charge. Got the point?
Okay.
So we'll have O
Yeah.
negative and we'll have a H positive and we'll have the structure. So now we are adding some base. That base can be NaOH or KOH, any base in small quantity. So you understand that NaOH, how does it break down? It breaks down in the form of Na plus
OH
and OH
minus.
negative. This OH negative will do what? This OH negative will attract H plus and we will have HOO. O is keeping its own electrons and H is electron. So we will have water here. Are we understanding my point? We will have a water
Yeah.
here. And because we will have a water here, so this is going to be a hydroperoxide ion. This is actually going to be a hydroperoxide ion. Are we understanding? Because this is a
Yeah.
hydroperoxide ion, because this is a hydroperoxide ion, so we will have HOO negative and water. Understood?
Okay.
Got it? Now, this is there, right? Now, how does this hydroperoxide ion attacks? Now, understand, it's a highly unstable anion. highly unstable anion. Why, what makes it highly unstable anion? Because O negative is okay, justified. O can hold a negative charge. O wants to gain electrons. O has 1, 2, 3, 4, 5, 6, 7, 8. This O
Hmm.
has its octet complete. Perfect. But it has another O just besides it, which has a lone pair. And because this lone pair and because of this lone pair, it is consistently pushing this no, negative charge. This negative charge,
Hmm.
because of the negative charge, it is completing its octet, perfect, getting the stability. But because of another oxygen just in adjacent to it, it is acquiring a negative repulsion, and that negative repulsion makes the anion highly unstable because there is a lot
Okay.
of movement in it. Because of that, what happens? We will have O, O, H, and hence what do we have? This O, O, H, which is my hydroperoxide anion. It has 1, 2, 3, 4, 5, 6, like that. Okay. And it donates one
Hmm.
of its electrons to boron, keeps one with itself. So which
Right.
electron is it donating? It is donating that electron which is extra, which it actually fetched from H. Yes or
Okay.
no? So
Yeah.
it is going to donate that electron. So it becomes neutral. And borane is getting
Right.
that extra electron. So borane acquires a negative charge. All right. So borane acquires
Okay.
a negative charge. Understood my point?
Yeah.
So we will have B, CH2, CH2, CH3, another CH2, CH2, CH3, another CH2, CH2, CH3, and we will have a O, O, H. Got the point?
Okay. Yeah.
And then you understand that O repulsion still holds, and and boron is acquiring a negative charge. You understand?
Yeah.
So because of this repulsion, boron's negative repulsion, BO bond is not breaking down. So what happens is repulsion is there, this bond is automatically weaker. So OO bond, OF bond, NN single bond, NF single bond. These are weaker bonds. Why? Any element which is highly electronegative, just these topmost four electronegative elements we have, right?
Yeah.
Their bond is highly unstable. Their single bond is highly unstable. If you talk about a
Okay.
bond between O
Together.
and F, reason there is a repulsion between O and N. There is a repulsion between O and N. N and Cl. There
Okay.
is a repulsion between N and Cl. You understand my
Hmm.
point? So
Yeah.
there will definitely be a repulsion between ONF, ONN, NNCl like that. Understood my
Okay.
point?
Yeah.
Their bond is highly unstable. Got it? So as and when it
Hmm.
gets a chance, so even OO single bond, NN single bond, FF single bond, they're not stronger bonds. They are weak bonds. And their in reason for being a weak bond is the oxygen-oxygen lone pair repulsion, the fluorine-fluorine repulsion. Are we understanding my point? So
Okay.
what does that mean? Just understand. So this bond breaks and O and this O takes away its electron. So OH negative is back to medium. That clearly indicates that this base we have added acts as a catalyst.
All
Got the point?
right.
So you have to know the mechanism so as to tell there are several intricate questions to it. What kind of intricate questions? One, what kind of transition state is formed? How many member
Okay.
transition state is formed? What is the role of NaOH? Is it acting only as a base? Is it acting as a catalyst? Or is it acting as a, which anion is attacking borane? So is it BH3 or is it hydroperoxide anion? So these kind of questions are asked. So why
Oh,
people fail or why people basically find that paper difficult is because they do not study the mechanism, right? So
right.
each and every aspect, every step is a question in mains exam. If you learn the mechanisms, chemistry is easy. If you miss out the mechanisms, you find chemistry paper difficult. That's the thing. Got the point?
Right.
Okay.
Yeah.
So you have to basically work on the mechanisms and then that's it. Okay. So now
Okay.
we have this. Now, what is happening? The moment it loses electrons, so realize, so we'll have O positive because OH is lost. The remaining
Right.
will have CH2, CH2, CH3. We'll have a CH2, CH2, CH3, and we'll have a CH2, CH2, CH3. Understood my point?
Yeah. And there's a negative one
Got it?
B, right?
Right. And now O cannot hold up and be a negative charge in B. Now O cannot
Yeah.
hold a positive charge. So this exactly. And boron also is already highly negative. So what is happening?
Hmm.
Now this shift takes. This entire structure shifts here with both of its electrons. You understand? So it takes its electron
Okay.
and shifts on boron. So we will have B, O, CH2, CH2, CH3. And because this group has already taken, see, understand, carbon's electronegativity is more than hydrogen. And
Okay.
we have just studied that out of B and H, H carries a negative charge, boron carries a positive charge. That means
Uh,
if hydrogen is more electronegative than boron and electronegativity of carbon is more than that of hydrogen, then definitely in the BC bond, the electrons are shifted towards carbon. And because the
yeah.
electrons are shifted towards carbon, the extra electron that boron had got because of oxygen has now been shifted to carbon.
Okay.
Understood my point?
And
So
then the
that's
carbon
how we
itself
have this.
shifted to oxygen.
Yes. So now you
Oh,
understand. So we are left with again CH2, CH2, CH3 and CH2, CH2, CH3. Got the point?
yeah.
Going forward, then we'll have another hydroperoxide ion because the base is still there, hydrogen peroxide is still there. Base takes away one H, so we are left with this anion. It again attacks the p orbital. Then OO bond is
Okay.
unstable. Then this bond breaks. O acquires a positive charge. Then another CH2, CH2, CH3 shifts. So gradually, what happens to boron? All the three CH2, CH2, CH3, O, CH2, CH2, CH3, O, CH2, CH2, CH3, they all convert into OCH2, CH2, CH. Understood my point?
Okay.
Got the point? That is
Yeah.
one part. And then we what do we do? Then what do we do? Again, O is highly electronegative. Again, O
Hmm.
is highly electronegative. So if this bond breaks, O acquires a negative charge, B acquires a partial positive charge. O acquires a partial negative charge, B acquires a partial positive charge because the bond between B and O, electronegativity of if O is very, very higher than boron. So then when we
Hmm.
do its hydrolysis, little bit of acidic water. So how does water break? Water breaks like H plus and OH negative. So
Okay. Yeah.
H plus goes here and OH connects here. So all the three bonds are broken down by the addition of three molecules of water. So we will have BOH, BOH, and BOH. And we'll have CH3, CH2, CH2, OH. Understood my point or no? So this is basically going to be what? This is going to be a propanol. And this is going to be
Okay.
my boric acid. So boric acid is my side product or byproduct.
And
Okay.
propanol is what you mainly get.
Yes. So now, just if you look from the starting point, normal addition of water says what?
You would have gotten
Normal
propanol
addition says
even
what?
then, right?
Sorry.
Even in normal addition, you would have gotten propanol.
Then we would have got propane 2 ol because then Markovnikov's rule is followed. Here, if you look,
Right.
OH is connected to that carbon on which a less stable carbocation would be formed,
Right.
right? But actually, in this step, there is no carbocation formation actually taking place.
Hmm.
Here, transition state is taking place. So this reaction looks like as if it is an electrophilic addition. And it is actually, up till a certain stage, it is actually electrophilic addition, but not via
Entire.
a carbocation formation, but via the transition state form.
Right.
Okay. So there is no intermediate to it. There is only transition state in the electrophilic addition of water or hydroboration oxidation.
Got it.
Got the point. So this is
Yeah.
it we have. So how do we say to this? We will say that this addition of water looks like the addition of water looks like that of the anti-Markovnikov loop. Looks like that of the
Marco.
Markovnikov. Understood my point?
Yeah.
It
What
looks
is
like that of the
anti-Markovnikov
anti.
though?
Right. All right.
Okay. What is anti-Markovnikov?
See, Markovnikov's rule says that the negative part goes to that carbon which has more stable carbocation.
Right.
Anti-Markovnikov's rule would be the negative part goes to that carbon with the least stable carbocation in the structure
Okay.
across the double bond. So if you have this and if you have water, then what is
Hmm.
exactly happening? Water shall break down into H plus and OH negative. So then you will have CH3, CH and CH2. So here the carbocation, if it is formed, will be least stable across the double
Okay.
bond because we have only two carbons on which we can actually study the possibility of the formation of a carbocation. You understand?
Right. Yeah.
Got the point?
Yeah. So when do you use anti-Markovnikov and when do you use Markovnikov? Like, how would you know?
You will have to remember that in hydroboration oxidation, it is anti-mercury. That is
Okay.
what you have to remember. Once you practice the mechanism, you recall it to yourself that in in hydroboration oxidation, the final product looks like that of a anti-Markovnikov's, and you have to practice Markovnikov's rule multiple times. What is
Okay.
Markovnikov's rule? The negative part goes to the carbon with more stable carbocation.
All right.
Got it?
Yeah.
Right? So that's how. So, but we know for the fact that making product, ये तो जुगाड़ है ना एक तरीके से आप समझो. This is a trick or hack that finally you add OH wherever you find the least stable carbocation. But you know the
Hmm.
mechanism. In reality, there is no carbocation being formed in the mechanism of hydroboration oxidation. But it
Right.
looks like as if the addition of water has taken place.
Hmm.
The addition of water has taken place with regards to the fact the final products looks like that of the uh, anti-Markovnikov's product.
Right.
Got the point?
Hmm.
So that's the idea. That is hydroboration oxidation. So now if I ask you to make a product here, see, listen. If I ask you to make a product here, CH3, C, CH3, H, CH, double bond CH2. I simply add water and H plus. I want you to tell me product A. And to the same thing, I add BH3, then I add ROH, alcohol, first. Second, we add H2O2 in the presence of a base. And third, we add
Hmm.
water, acid. Three steps. So you have to remember the reagent. The moment you see borane with water, hydrogen peroxide, you know that these two together mechanism we have studied. So you
Yeah.
have to remember the mechanism along with the reagent. The moment you look at the mechanism, the reagent, simply write down along with it. While practicing, it is HBO's reagent.
Okay.
Got it?
Yeah.
That when all of these are used together, then you have hydroboration oxidation. And that you can remember by practicing the same mechanism multiple times. Let's say the hack is to write down each mechanism 5 to 10 times with understanding. 2, 3 times by looking at the mechanism, 4 to 5 times without looking at the mechanism. If you do
All
that,
right.
then and every time when you are actually writing down the mechanism without looking into the solutions, explain that mechanism to yourself. कि ये यहाँ गया, ये यहाँ गया, ये टूटा, ये ऐसे घुमा, shift हुआ. The moment you start doing that way, I think that makes your chemistry easy.
Okay.
Okay. So you'll have this. Now, I want you to tell me two products, A and B. Now, how will you do? In hydroboration
So,
oxidation, there is no rearrangement. Across the
right.
double bond, this is the more stable carbocation, this is the less stable carbocation.
तो
Hydroboration
लेस तक ऊपर
oxidation
जाएगा
follows
anti-Markov.
anti-Markovnikov's addition.
Right.
So what
So
do you think we'll have? We will have a
you
CH3, C, CH3, H,
3-methyl
CH,
butol
CH2,
butanol.
and we'll have OH here.
Yeah.
So, but if I talk about this is normal acidic hydration,
Right. So here you'll get one,
right?
two.
Right?
The all will come on the second position.
Right. So we'll have an acidic hydration here. So then what
Hmm.
do? We shift the bond, recall the mechanism. A carbocation is formed here.
Right.
That
That will
carbocation
get.
to that H will be connected, but hydride shift will take place. The carbocation will become 3 degree.
Yeah.
and then the final product will form. So the final product here will be CH3, C, CH3, CH2, CH3, and here OH will attack. Because actually, is it OH attacking or is it the alcohol or full water molecule attacking?
Um, Initially the full water molecule attacked, then
And then
that's
H
split
plus.
into H plus OH.
So finally, we get to see that it is the OH attacking.
Mm.
Got the point?
Yeah,
So that's how we have the structure. So this is the difference. This is product A and this is B. Are we understanding?
yeah.
Any doubts in this? Just
No,
got the point?
yeah,
Any doubts in this? Just
no
right.
doubts.
So that's how we have hydroboration oxidation.
Oh wait, actually, yeah, before during the first few steps, you said when the third.
All questions can be formed. So they seem to be difficult. Why? Because we don't study the mechanism. That's the only point where the child finds chemistry difficult.
Right.
So you need to make a notebook, a thick notebook, start writing mechanism. Every mechanism to be written down at least in a year 10 times. 2 times, 3 times by looking at the solution, 7 to 8 times
Without.
on your own. And
Got it.
self-teach yourself. That's how you do chemistry.
Okay.
Okay. Right. One more question. Just so we have another structure here. So let's say I give you this question. Now, what do we have? Okay. You know resonance, right?
Yeah.
Okay. Well, this is a structure, and
Hmm.
I want you to add water to it in the form of H plus. Okay.
Okay.
So that's
So
step one. Make the most stable carbocation for the very first time. Now we have a pi bond here, right?
yeah, that'll
Either
break.
the positive charge will be here or positive charge will be here.
But
When I
it'll be on
look
the
at the
second
positive
one.
charge, this one, it has
Hmm.
3 alpha H and it also has resonance coming from benzene.
Right.
So I'm going to make the bond, take the bond this side. Once I
Hmm.
break the bond, what do I get? I get CH3. See, for the very first time, my instinct should be to make the most stable carbocation so that I don't have to perform any kind of, you know, any kind of shifting. So I'll have
Right.
CH negative and we'll have C. And this benzene group is actually in short form. Going forward, I'm going to write it down as phenyl.
Okay.
And CH3, I'm going to write it down as methyl. These are the notations that kids don't understand. And then we have this, right? So then what exactly
Yeah.
happens? CH3, CH negative, C, benzene, and methyl. Got the point?
Yeah.
So we have this. Once we have this, you know that this is positive and H plus connects here
Hmm.
because H is positive. So H plus attacks on this negative. So what do we get? We get CH3, we get CH2, we get C, we get phenyl, and we get methyl. And this is positive. And to this, water is going to attack,
Right.
and O will have a lone pair on this. And O is going to donate one of its electrons here. So we'll have a CH3, we'll have a CH2, we'll have C, we'll have
Hmm.
this, and we'll have methyl. And here OH2. Got
Okay.
the point? O cannot hold a positive charge, H is released. So this is going to be my product. Got it?
Right.
And if you realize that this carbon here, this carbon carrying a positive charge is actually a 3-degree carbo.
Cation.
Got the point?
Yeah.
Okay. Now,
Hmm.
sometimes the question is like this. The question says what? See, do you get this point? And here you understand that the rate determining step. What is the rate determining step?
The slowest step in the
The
reaction.
slowest step. Why it is the slowest step of the reaction?
Because no matter how fast the other ones are, this is the one that will decide.
Why?
Because till this doesn't happen, like the reaction cannot proceed, right? So if it's the slowest step, everything else will happen and this will keep happening. So that is what makes the difference, right?
Yeah, because all the steps will happen after this. This is the
Yeah.
slowest step, right? So it is going to
Yeah.
take the maximum time. Now,
Hmm.
now understand. So basically, if I give you this question, if I give
Right.
you this question, now there is this question which says CH3 plus H2O. This is one question. Another question is CH3 plus D2. The question says the rate of this reaction is R1. The rate of this reaction
Hmm.
is R2,
Okay.
right? So then
Hmm.
you have to tell. So the question will be something like this: R1 equals to R2, R1 greater than R2, R1 lesser than R2, and none of these.
Okay.
Like that. Now, you have to understand what is the rate determining step. Now, this is going to break down.
Hmm.
So when H2O bond breaks, so you understand that H2O bond actually is not breaking down. It is H2SO4 that we add. That H2SO4 that we are adding, its H plus is capable or is responsible for breaking this bond.
Yeah.
Right? So H2SO4 though is remaining same in both the reactions. So when H2SO4
Hmm.
breaks, it gives me H2SO4 in the water form. It gives me H plus and HSO4 negative. And the
Right.
other part also breaks. So it gives me what? It gives me CH3, CH, and CH2 negative.
Hmm.
CH3, CH, and CH2 here. And H connects here and a carbocation is formed. And that's my RDS, rate determining step. That's my slowest step. So the opening of the pi bond and attacking of H plus, this negative charge, is actually taking all the time. And
Okay.
then water will attack. Now, attack of water is not the rate determining step. Now, have a look
All
here.
right.
We are going to have CH3, CH equals to CH2. Got the point? Once we have
All
this,
right.
right? Once we have this, again, H to the 4, H plus is opening the bonds. H plus is
Hmm.
connecting here. So we'll have CH3, CH, CH2H. Positive charges being formed. Are
Okay.
we understanding? And hence,
Yeah.
what do you mean by this?
So this would mean
That
R1 is
again,
equal to
now
R2.
D2O is going to attack. The products will be different, no doubt.
Hmm.
Oh, this is heavy water. D2O is
Yeah.
heavy water. H2O is normal water. O will attack. It is
Hmm.
going to form CH3, CH, CH3, OH. O cannot hold a positive charge. H plus is released. Perfect. Got it?
Right. Yeah.
Now, here, what is released? O attacks,
OD. Yeah.
CH3, CH, CH3, OD. Here, D plus is released. Now, look at the difference. That means the carbocation formation was both, in both of them was same. So I will say rate 1 is equals to rate 2. End of the story. Because the
Yeah.
slowest
So
step was the same in both of them. Then more or less the speed was same. But if I ask you the product, will the product be same in both of them? No.
no.
The products will be different because the final product depends upon the reagent also.
Okay. So you have to remember which is the rate determining step for a reaction, right?
Yes, yes,
Okay.
right. And also look at the product. Look at the product.
Hmm.
We have CH3, CH3, OH, and H. So three groups are different, but one group is exactly similar to this one. That means it is not a chiral carbon.
Right.
It is not a chiral carbon. And because it is not a chiral carbon, it means what? Because it is not a chiral carbon, it means what? Tell me.
That it doesn't matter whether OH gets
So
attached.
only one product is formed. Because if it would
Okay.
have been a chiral carbon, then I would say one is dextrorotatory product and one is a levorotatory product. Understood my point? Or not?
All right. Yeah.
Any doubts in this?
No.
Understood?
Yes.
Right. So this is how you're going to have this. Understood or not?
Hmm. Yeah. So every time there's a chiral carbon in the product, I can just multiply the product by 2, right?
Yes.
Okay.
Understood? Any doubts in this? Just tell me.
No.
Got it? So that's how it basically works. This is one part. Now, what question is framed? Now see. The question says, what is the role of H2SO4 in first reaction? So I say that H plus was utilized, H plus was released.
Hmm.
So it acts as a catalyst.
Right.
But here H plus was utilized, but D plus was released,
So not a catalyst.
not a catalyst. So they are
It
going to give you
becomes a
two
reagent.
reactions and they're going to say, yeah, it's a reagent, or you will say H2SO4 is acting as
Okay.
an acid whose H plus is getting consumed.
Hmm.
So where do you think the concentration of H2SO4 will decrease with time
In the second case.
in the second? So the mechanism tells you this. Now these are advanced level questions. You understand? Because if you understand the mechanism, you know at what step what is happening, and they makes your advanced level question simple.
Hmm.
Got it? So concentration of H2SO4 does not remain same in all the cases.
Yes.
That's the point.
Okay.
Got it? Easy?
Yeah.
Not
Yes.
difficult, but just the concept.
Yeah.
Okay. So the question would be framed like this. In reaction 1, H2SO4 acts as a catalyst. Reaction 2, H2SO4 does not act as a catalyst. True or false?
Hmm.
अब true or false बताते रहो. Yes, sir. तो ये सारी चीजें
Both are
आती हैं.
true. Yeah.
ठीक है?
हाँ.
Okay. So this is one part. आज इतना ही करेंगे. We'll keep a 15 minutes class today. Not a longer class. कल थोड़ा extra कर लेंगे. ठीक है?
All right. Yeah.